Now that we have discussed about linear equations in two variables x and y, let's try to apply in real life and see the application of a line in real life situations. There are many situations which demand for linear equation, like speed, velocity, all are related to the linear equation. Velocity time graph is a linear equation, etc. So let's see more of real life applications of linear equation through one of the real life situation. Now, as we have seen that in lower classes we have learned the conversion of centigrade to Fahrenheit, the temperature conversion which we have learned about centigrade to Fahrenheit or Fahrenheit to centigrade is what we are going to see as a real life situation. For example, real life applications of a line or a linear equation. Let's see how we can apply this in real life situation. For example, I have temperature conversion equation. Usually we have the temperature conversion which is done through the mathematical calculated equation through the data collection, which is given to be F equals 9 by 5 C plus 32. Temperature conversion equation F equals 9 by 5 C plus 32 is what is the linear equation in x and y. So using this temperature conversion equation, F equal to this is used to calculate initially the Fahrenheit when C is 30 degrees, and secondly the centigrade when the Fahrenheit is 12 degrees. So let's see how these conversions can be done for the given real life situation. So I have in the initial case the centigrade degree which is given in the temperature of 30 degrees, through which I want to know its respective Fahrenheit temperature. So for this centigrade temperature, I would like to find the temperature in F, its conversion in Fahrenheit scale. So let's see how we can do that. The given conversion equation, the linear equation, is F equals 9 by 5 C plus 32, which is clearly in the form y equals ax plus b. Here F is assumed to be the y coordinate and C is assumed to be the x coordinate, where y equals 9 by 5x plus 32. That is, when I take the x-axis and the y-axis, this is Fahrenheit, this is centigrade which comes in x-axis, and the Fahrenheit which comes on y-axis, is how we understand graphically connected with C and F, C for x and F for y. The Fahrenheit is 9 by 5 plus C plus 32. My question 1 demands for finding F. To find F when C is 30 degrees. The value of C is 30 degrees, which when substituted in to the given problem, f equals 9 by 5 times of c plus 32. So the value of c as given in the question as 30 degrees substituted to be 9 by 5 times this plus this, which on further simplification gives us 5 ones 5 6, 6 nines 54 plus 32. $86. Therefore, my F is 86 degrees Fahrenheit. So 30 degrees centigrade converts to 86 degrees Fahrenheit out here. Is how we understand the conversions which can be done given the linear equation y equals ax plus b, y for f and x for c. Next, let's see the next problem about finding c when f is 12 using the same linear equation. Secondly, my second part is about finding c. So to find c, let's see how we can find the centigrade temperature for the Fahrenheit. F is given to be 12 degrees Fahrenheit. That implies when I substitute into the given equation, 12 is 9 by 5 times c plus 32. So when F is 12 degrees Fahrenheit, I convert by substituting to F equals 12 and then simplifying to find c. Now it's about finding c, so I take this to the left hand side. 9 by 5 c plus 32 is 12. That implies 9 by 5 times c is 12 minus 32. 32 comes to the right as minus 32. That implies 9 by 5 c is 12 minus 32 is minus 20. And then which on cross multiplication gives us 9c is 5 times minus 20, which on further simplification gives us 9c is minus 100. That implies c is negative 100 by 9, which approximately converts to minus of 9 ones 9 and then 10, 9 ones 9 and then 10, 1 1. So approximately c is negative 11.1 degrees Fahrenheit. Is how we understand the conversions as done through the Fahrenheit. So F equals 12 implies C equals negative 11.1 is how we can find the values of the temperature conversions using the linear equation. My next question here would be, when will the two temperatures be equal? Is there any possibility to find when the centigrade and Fahrenheit scale reach to the same value? So let's see if we can identify the temperature at the break-even point. That is at the point where the two temperatures C and F are equal. So let's continue with the continued question out here. So my next question out here is, when will the two temperatures F and C, when will the two temperatures on F and C scale meet is my question out here. So when do they be equal? Let's see if we can find that point where F and C are equal. In order that we do this problem, it is very simple that we assume that the two temperature scales are equal and then find the value. A reverse process of working out. So assuming that F equals C, let's try to find the value utilizing, of course, the linear equation. Real life applications of a line. Now that F equals C, I substitute F equals 9 by 5 of C. So my F being C replaced with C plus 32. So here my F gets replaced with C. Is how I understand the substitution. Now let's find the value of C by taking all C terms to the left. So here I get this to be 9 by 5 times C plus 32 is equal to C, which on further simplification gives 9 by 5C minus C equals negative 32. 32 comes to the right as minus 32, C goes to the left as minus C. So taking the LCM, we get this, which on further simplification gives 4C by 5 is minus 32. That implies C is 4 ones, 4 eights, so minus 8 times 5. Therefore, C is minus 40, and F equals C implies is how I can identify the values of F and C being equal to 40. Therefore, when the temperature reaches 40 degrees centigrade or 40 degrees Fahrenheit, the two temperatures meet on the same scale. That is, (40 degrees centigrade is exactly equal to 40 degrees Fahrenheit. Only at 40 they both are said to be same. 40 degrees centigrade equals 40 degrees Fahrenheit. Is how I understand the applications of line in real life situations. Temperature conversions being one of the real life application. Let's reconsider the example problem F equals 9 by 5C plus 32. The temperature conversion formula in its linear form. If my question was to draw this, clearly this is a linear equation in two variables F and C. This is a linear equation in F and C. Therefore, this must be a straight line. Its graph is a straight line. That is, when I take this on x-axis and y-axis, my centigrade scale on x-axis and my Fahrenheit scale on this gives me a line with y-intercept cutting at 32, and my slope is positive, so it cuts x-intercept, x is 0, when yf is 0, I get minus 32 somewhere out here. So this is how I get the line when I sketch on the xy coordinate system or FC coordinate system. A line in its temperature conversion is a straight line in the Cartesian plane, as can be drawn using the table of values. Sketching a line for a real life situation.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.